We're going to review current, electric current, 电流. So, some vocabulary: battery, 电池, capacitor, 电容, charge, 电量, electrolyte, 电解质, electrode, 电极, terminal, 接点, short circuit, 短路. All right. So, number one, battery. So battery, the symbol looks like this. So one long, one short, plus, minus. This side is plus, that side is minus. It's a device to convert chemical energy into electric energy. Or you can say it's a device to store electric energy chemically. Two, a capacitor, 电容. So two equal lines. Of course, one side is positive and one side is negative. It's a device that we hold the electric energy. So you don't convert chemical energy to electric energy. You're just holding it so you can use it at anywhere that you want it to. So battery, we have pictures here. We'll go through that later. Number three, total charge of a battery, 电量. So ampere is a unit for current. So ampere times hour become a unit to describe the total charge of battery. So you want to say like a life of a battery. So this is a good indicator. So life of a battery. So how much charge in a battery? Number four, electric current. So I is a symbol for current. So Q is the charge. Delta Q means in the delta T time, how much of the Q has gone through a cross section. So there's a wire here, and then you look at this cross section right there, and you say, well, how much coulomb, right? The charge is in terms of coulomb per second. It's going through this area. So coulomb per second is the unit for ampere. Number five, electrolyte, 电解质. So it's the chemical solution, the liquid here, inside here, the liquid right there. This is the liquid used in a battery. So this is the battery. This is the battery drawing. And we have a plus. So terminal is the one that above, right here. This is terminal, positive terminal, negative terminal. And electrode, 电极 is the whole thing. The whole thing is electrode. And this side here is made of zinc electrode. So terminal and electrode. Make a distinction there. Electrolyte is used there. So complete circuit, it's a closed path for I. So if I go and draw a closed path like that, like this, so then the current will go from positive and then to negative, and then inside here you have this path, basically, chemical path. So you have this closed path. So that is a complete circuit. It's a closed path. Open circuit, it's only part of a complete circuit. So that's an open circuit. So if you have a closed path, I'm drawing a resistor here, we'll introduce later. And you have a battery, and all of a sudden, this is broken. So something is broken. So let's see. There. Ah, not too good. Okay, so it's broken there. It's broken now. So that's an open circuit right there. This is called open circuit. There you go, right there. You have an open there. So open circuit is not the same as short circuit. So short circuit is this. Resistor. Okay. And all of a sudden, something happened. So like that. Okay. So the resistor is not gone, but it looks like it's gone. So now the resistor has some kind of contact. Sorry. Some kind of contact. So then actually create this path here instead of going through this resistor here. So now you have this path here because there's a contact. There's a contact. Some components are having contact. So now that is a short circuit. See, that's an open circuit, but this is short circuit. So short circuit, right here, the R becomes smaller, resistor becomes smaller, resistor drop. And open circuit, resistor become infinity at that location. Okay? So short circuit, 短路 is a low resistance. Resistance we will learn later. It's R. It's in terms of ohm. Lower resistance path of a circuit than intended. Yeah. And so in this case, it would create excessive current. And it can have fire. It's dangerous, and it can have a fire hazard. 火灾. Ground. Ground is, it's earth. Like that's one really good example. So its symbol looks like this: the 3-bar, long, short, long, medium, short. So it's a reservoir, like a 储存的东西 reservoir 储存 of a plus and minus charges. So in the earth, you have lots of plus, lots of minus, lots of plus, lots of minus, lots of plus, lots of minus inside the atom. So that is a ground. Okay, we're going to continue. Number 9, Ohm's law. So Ohm's, ohm. V equal to I times R. V 电压 R 电阻 I 电流. So if you look at a complete circuit, battery, current, resistance, Ohm's law is governing the relationship between V, I, and R. The larger the R for a given current, the voltage across the R is larger. The larger the I, given the resistance, the larger the voltage that's going through this resistor. The unit is volts for V, ampere for I, ohm for the resistance, resistor. So all V equal to A ohm. So this is like the oil pipe that going through interstate highway. They use this to make sure when the temperature expansion happen or contraction happen, that it won't break. So it's a relationship between current and voltage given the resistance R for the resistor. So resistor is the device. Resistor. Yeah. Resistance, it's the difficulty for the current to go through. Right? This is resistance. This is the difficulty level. Okay, resistance symbol is this. It's different from the spring. Spring's like this. This is spring. So it's a device to control the amount of current in a complete circuit. So in the complete circuit, if you give it a larger R, then you will see less current. Yeah. If you want to have more current, then you have to reduce the R. Or you can increase the V. Number 11, resistor color code. So we have color here. Can be black, brown, red, orange, and more. And this number corresponds to this color, 0, 1, 2, and the multiplier and the torrent. So we have a resistor here. We got rings, 1, 2, 3, 4. The first one is red right now. So you go look it up, red right there, and the number is 2. So we put a 2 there. The green is 5. So we put a 5. In yellow, it's this one here is for the multiplier. So that's first digit, second digit. This color ring is for the multiplier. The last one, the last ring is for the torrents. So the multiplier says the yellow, and yellow for the multiplier is right there, 10 to the 4. So we got 10 to the 4 there. Torrents, it's brown color, so brown right there. And torrents is here, so it's 1%. So we got 1%. So then you write it down, first digit, second digit, the multiplier, and then the torrent. So 25 times 10 to the 4 ohm. And this one here determining how good is your resistor. So the smaller torrents, the smaller, then the better. Means also more expensive. So more dollar sign. All right, so ohmic material, and non-ohmic material. So ohmic material is referring that a material follow the Ohm's law really well. So this is V is proportional to I. So that's called ohmic because it's a linear proportional. So ohmic material follow a linear proportional relationship, I and V. So this one here just means proportional. It's not an alpha, it's a proportional sign. Non-ohmic material, so it can be like this and it can be like that. So it's just not a line that goes through the origin. So it's not linear proportional. So that's a non-ohmic material. So this relationship does not work. So V is not equal to IR for the non-ohmic. Number 14, resistivity, ZO. So R is equal to ZO times length divided by area. So cross-section. So for a wire, you have the length of this wire. If you make this length longer, then the R for the wire, R of this wire, will become larger. The longer the wire, the higher the R. If you make this area smaller, then the current is harder to go through because it's too tiny. So then the current has to fight with each other. The electron has to fight with each other. So the smaller the A, the more difficulty to go through, so the larger the R. And the unit for the ZO, this one here is ZO. ZO, a Greek letter ZO. It's pronounced here as RHO, ZO. Ohm meter, so that's a unit. So you can see ohm meter here, ohm meter, and this is meter, that's meter square. So then ohm meter, and then times, basically this cancel 1, so here meter, so then cancel meter, then it become ohm. Okay, we'll continue. Okay, some more vocabulary. Fuse, 保险丝 circuit breaker, 断路器 Okay. ZO, resistivity, alpha, temperature coefficient of resistivity. All right, so 15, temperature dependence of resistivity. So that means the resistivity zone which used in this relationship can change depends on the temperature. The higher the temperature, usually the higher the resistivity. And this alpha is material dependence. So it can be different for different material, copper, silver, aluminum. Number 16, zone resistivity, alpha, temperature coefficient of resistivity is associated with materials. The smallest for the zone is silver. So this is the best conductor. Second best, third best, the last best. I mean, not the last best, the fourth best. So copper is used more frequently in the household, in the home, and commercially because they are cheap. Aluminum is used because their density is smaller than the copper. So in the transmission line, this transmission line that goes from, goes from hundreds of miles across states, this material is usually aluminum because they are less weight, lower density. So transmission line using aluminum because lower weight per unit L. Number 17, electric power, P. So P is I times V. If you expand the V term, then V is equal to IR as in Ohm's law. And then you multiply them, so I square R. And then you replace I using Ohm's law equal to V times V divided by R. And then that becomes V squared, E squared divided by R. So those are the IV, I square R, V squared divided by R. Depends on situation, you use different ones. Depends on which one is constant. So which one is constant? Right? And what do you want to compare? Brightness, 亮度. So it's the power. If your area is the same, then you can using power to represent brightness. If the area is not the same, then brightness is the intensity. So P power divided by area. And this I is not current, it's the intensity. 19, parallel circuit is used at home because every appliance is 电器, is independent this way. So if your air conditioner using more currents, so the fuse is burned and the circuit breaker jump up, then it won't impact your television. It won't impact your light bulb. So you want it to be independent at the household and many other commercial building too. 20, the units. So ampere is for current, coulomb is for charge. So coulomb per second is ampere. Volts is for voltage, electric potential. Joule is for energy. So energy, E, is V times Q. So V is energy per charge. Electric potential is energy per charge. Watts, joule per second. Joule is for energy. Or P is equal to IV. So P is watts. I is using ampere. V is volt. Ohm is volts divided by amp, like in Ohm's law. Right? Keep learning physics. Have fun. If you're interested more, subscribe. 订阅. Bye bye.